The realm of re-establishing gait is ever expanding, with over 6.8 million Americans requiring the need for some sort of assistive mobility device. Ranging from canes to wheelchairs, science has always been in the pursuit for treating injuries such as arthritis, nerve damage, or even drop foot. The condition of drop foot is the inability to raise the front portion of the foot due to muscle paralysis or muscle weakening in the tibialis anterior muscle. This inability leads to reduction in dorsiflexion, a flaccid response to loading on the foot, minimum eversion and inversion strength, and little to no spasticity. In 2016, it was reported that out of all the Americans that have the condition of drop foot, only 1% wear some sort of brace or assistive device. This leaves the other 99% to struggle on a daily basis that might even lead to the overextension or further injury of healthy muscle cells. To address this impeding problem, our group came up with a design called Motofoot. Motofoot is a motorized drop foot correcting splint that seeks to detect the foot position during gait cycle and correct the foot posture in order to restore the balance and stability to the weakened forefoot. This device consists of three main sensors: the accelerometer, the goniometer, and the microswitch. The accelerometer is placed on the medial side of the leg and detects the X, Y, and Z position of the foot. Movement in these coordinate planes signifies that the patient is attempting to walk. The goniometer indicates the angle from the plane of the forefoot to the horizontal transverse plane. This represents the angle of drop foot in real time. When the goniometer reaches 120 degrees, a condition set by the physician, the forefoot has reached its critical value. The microswitch was originally placed on the bottom of the foot. However, due to its bulky features, it will be placed on the protoboard as controlled by the physician. When the switch is pressed, a false indicator relays that the foot is planted on the ground. When the switch is released, a true indicator relays that the foot is in the swing phase and is ready to be corrected. When all three sensors are deployed, indicating that the forefoot has been dropped during swing phase, correction occurs and the gear-coupled pulley system acts to create tension forces upon the targeted metatarsals. Each of these four tension lines will extend down a compression sleeve with high contact surfaces in order to mimic the tendons within the patient's leg. After the contraction period, the following relaxation period ensures that all the coils are thus returned back to their original length in order to relieve tension stresses and allow the periodic gait cycle to repeat all over again. As technology and resources advance, not only will we be able to separate the protoboards from the splint, but we will also implement wireless technology between these two components so as to lighten the load upon the patient and provide greater ease and fluidity. The applied stepper motor will also be upgraded in order to offer a fast extension and retraction opportunity that will enable the patient to move at quicker speeds, such as sprinting to the point of athletic performance. Overall, through hard work and further progression of the original design, Motofoot can be used to address individuals and athletes alike in abolishing the mobility constraints that they struggle with on a daily basis.